Hey, Mr. Richards here. Today's 6th grade Unit 6 Lesson 8 anchor problems. We're going to get into some inequalities and now testing solutions of inequalities. In problem 1, try again. An inequality and an equation are shown below. 8x equals 32. 8x is greater than 32. Which value in the set of numbers 4, 4.5, or 5 is a solution to the equation? All right, let's just start there. If we look at 8x equals 32. Let's put in 4. 8 times 4 would have to equal 32. 8 times 4 is 32. 32 equals 32, so right away we have 4. If we put in 4.5, you wouldn't have it. 5, it would be 8 times 5 is 40, so that's not going to work. Then, what about the inequality? Which value in the set of numbers 4, 4.5, 5 are a solution to the inequality? Interesting. Let's test that 4 again. 8x would need to be greater than 32. 8 times 4 would need to be greater than 32, and we've already done 8 times 4, that's 32. Is 32 greater than 32? No, that's false. That's not true. So 4 is actually not a solution to the inequality, even though it's the solution to the similar equation. Put in the 4.5 now. 8 times 4.5, is that greater than 32? Well, 8 times 4 is 32. 8 times a half is 4, so this is going to be 36. We need to be greater than 32, and sure enough, that's true. So 4.5 is a solution to this inequality. And lastly, what about 5? Is 8 times 5 greater than 32? Well, 8 times 5 is 40. Is 40 greater than 32? That's true. So apparently 4.5 and 5 are the solutions to the inequality. Neat. So any number bigger than 4 looks like it's going to be solutions to this inequality. So you can almost say, as long as x is greater than 4, we have solutions to that inequality. All right, problem 2. In which set of numbers are all of the values? See, you'll notice in the problem set today, because I did the problem set first, that I've made a couple mistakes. But let me try rereading this now and seeing if it's me or if it's the question, or I don't know. In which set of numbers are all of the values solutions to the inequality 1 3/10 x minus 2 is less than 7? See, it was me. It wasn't the question. Man, I am sorry. Let's test some numbers, and there are some strategies here that you can use. Like I see there's 2 10s here. These 2 have 3s and things like that. So basically, though, I want to test the smallest number first to see if that's true. Let's try that. Let's test the smallest 0 first. If I did 1 3/10 times 0 for x minus 2, is that less than 7? Well, 1 3/10 times 0 is 0. And even though we haven't done too much with integers and subtracting them yet, you could use a calculator if you get to this type of thing, or just know what's numbers 2 smaller than 0. 0 minus 2 is negative 2. Is negative 2 less than 7? Yes, so 0 works. And so do we have any numbers in common here? We have a 3. Let's test the 3. Is 1 3/10 times 3 minus 2 going to be less than 7? Well, 1 3/10 times 3 is going to be 3 9/10 minus 2. Is that less than 7? You betcha. 1 9/10 is less than 7, so 3 is true. And so I know 3 is true here and 3 is true there. Let's try the 7. See if we can just figure it out right here. 1 3/10 times 7 minus 2 would need to be less than 7. Let's see, 7 times 3 is 21. So 1, carry the 2, 9 1/10 minus 2 would need to be less than 7. Is 7 1/10 less than 7? No, it's not. So 7 is not a solution. Everything smaller than 7 was working so far, right? So if 3 worked, we know 2 would work. If 0 and 3 worked, then 2 is in between the two, so we would know that would work. Let's test this. Let's test the 6. See what happens when we put a 6 in. 1 3/10 times 6 minus 2 is less than 7. 1 3/10 times 6. Let's see, 6 times 3 is 18. We 7 8/10 minus 2 would need to be less than 7. And yeah, that's going to work. 5 8/10 is less than 7. So 6 works. And guess what? Since 2 worked and 6 worked and 4 is in between the two, 4 is going to work as well. Neat. B is the answer. Problem 3, and just going to see what else there is here. All right, problem 3. Isabel is moving. Okay, let's try that again. Like I said, I'm having all kinds of difficulties today. Thank you for bearing with me. Isabel is moving her office to a new location. She is a box that can hold up to 40 pounds, and she's already put 18.5 pounds in the box. Isabel has several books that each weigh 3 pounds that she also wants to put in the box. The inequality 3x plus 18.5 is less than or equal to 40, where x represents the number of books can be used to determine how many books Isabel can put in the box without breaking. Which of the following number of books can Isabel put in the box without it breaking? Select all that apply. Let's start just by putting in numbers, I guess. 3 times 5 plus 18.5 needs to be less than or equal to 40. 3 times 5 is 15 plus 18.5 would need to be less than or equal to 40. Let's see. 15 plus 18.5 is going to get us 33.5, and that is less than or equal to 40, and so 5 works. My guess is we're going to come up to a number here that's not going to work, and then we'll just cross out the rest. Is 7 books too much, or are we going to fit it in? 3 times 7 is 21, and I write out the rest now. 21 plus 18.5 is going to be 39.5. We're barely scooting by here. 39.5 is less than or equal to 40, so 7 is going to work. What about 8? Or is 8 going to be too much and break the box and spill it, and there'll be tears and yelling and screaming, and I told you not to put too many boxes or books in that box or else they're going to break and it's all your fault. I know, I'm sorry. 24 plus 18.5 is going to be 42.5. That's not less than or equal to 40, so 8 is going to be too many. And if 8 is too many, so is 10, and so is 15. So that's the last example. But as we look back through these here, part of the purpose of this lesson is to get us to try to understand inequalities and testing numbers a little bit better. And as we look back at this problem 3 here, there was a point where we could fit enough books. And so, you're going to get to the point where you can solve these and you'll be able to graph these on number lines. I mean, you look at this number line and it seemed to me that, 7 was true, 6 was true, could be true, 5 was true, 4 was true. So really, there's a point somewhere over here. If you could get fractions of books, perhaps. But, everything less than 7 books kind of worked. And so you could have a graph for that. If we go up to the first example, 8x is greater than 32. 4 seemed to be the point where things kind of changed, right? And so, if you look here and you were to look at this number line, and that is a line, trust me, I'm a math teacher. It's not a perfect line, but, for the circumstances, we'll call it a line, all right? If 4, 4.5, 5, 6, numbers smaller include 3 and 2 and things like that. We knew 4 wasn't a solution, but on this example, we saw 4.5 was, and 5 was, and guess what? 6 would be, and everything over here on the right side is going to be true for this inequality. Everything on the left side is not going to be true, because if you put in 3, 8 times 3, is that greater than 32? No, 24 is not greater than 32. So I know 3 is not true. We knew 4 wasn't true. 2 is not going to be true. 1 is not going to be true. And so the more you work with these, the stronger is not a word. Stronger is. The stronger you'll get, the more you work with these. And with that, we'll call that good. That's it for these anchor problems. Good luck.